Welcome grade 8s. In this video, we are going to take a look at reflection. If you haven't taken a look at the last video on coordinates and coordinate systems, I recommend going back and looking at that first before we go further in things here. So today we're going to talk about reflection, and we're going to start off with our grid system like we had before, and we have 4 different points that are on it. We have point A, point B, point C, and point D. And just to write those down as a bit of a refresher from last time, our point A is at coordinate 3, that's the X, comma 2, and that's the Y. Our B is at coordinate 1 on the X and -1 on the Y. Our C is at coordinate -1 on the X and -5 on the Y, whereas our D is at -4 on the X, that's how far left or right it is, and +1 on the Y-axis. Well, we're going to talk about reflecting today, and in order to be able to reflect a point, or as we're going to do later on, reflect a triangle, we need to first figure out what it's reflecting in. What's the reflection line, in other words? And the reflection line could be a number of different things. Sometimes we're told that the x-axis is going to act as our reflecting line. Sometimes the y-axis is the line that a point or shape is reflected in. And sometimes there's another separate line, an imaginary line that we call the mirror line. We're going to take a look at an example of that later on in this video. But for now, we are going to say that the reflection line, or that these points are going to be reflected in the x-axis. What that means is that this line here, this x-axis, is acting as the mirror or the reflection point for each of those lines. Now, in order to reflect a point in that line, we're going to go perpendicular to the reflection line. So if this is the reflection line, perpendicular means it's going in exactly the opposite direction. So the x-axis goes left to right, so perpendicular would be going up and down. And we want to figure out how far away that point is from the reflection line going perpendicular to it. So I threw a lot of terms at you there, but we're going to take a look at it. So if we start with point A here, I want to figure out how far it is from the reflection line, this x-axis, by going the exact opposite direction, so in this case up and down, and it is 2 points away. And so if I continue those 2 points down below at equal distance, but in the opposite direction, I get my reflected point A. And to show that this point is connected to point A, but is slightly different, it's a reflected version of it, we're going to put a little A and then put a tiny little line or a tick beside it. So we have point A was at 3, 2. The reflected image of A, or A with that one tick on it there, is still at 3, but now -2. Let's take a look at B. So B, this is the reflection line. Now we're below it here, so we're 1 away from the reflection line, and we're going to continue an equal distance past that line, 1 further, in order to get our new reflected point. B with a line next to it. So point B, when it's reflected, it's still at 1 on the x value, but now its y value becomes +1. C, here it is. It is now 1, 2, 3, 4, 5 points away from the reflection line. So we continue that up, 1, 2, 3, 4, 5, and we have point C, which is our new point here, which is going to be at -1 and +5. D is all the way over here. It is also only one spot away from the reflection line. I continue that one spot away, and I have my new reflected point D, which is at -4, -1. If you take a look at all of these points, when we reflect in the x-axis, the x value actually doesn't change at all. The only thing that changes is the y value. It went from 2 to -2, -1 to 1, -5 to 5, and 1 to -1. So by reflecting in the x-axis, the only thing that happens is our y value for our coordinate system changes signs. So that's kind of a nice, simple or easy tip if you're trying to figure out how that all works. Okay, let's take a look at another example down here. And in this example, we're actually going to create a bit of a shape. Right, so we're going to have a point here. This is still going to be point A. We're going to have a point here, point B, and then we'll have a point down here, which is going to be point C. The difference here is that we're actually going to connect all of these lines in order to create a triangle. So now that we have a triangle, it doesn't change how we solve the question. The difference here, though, is instead of reflecting in the x-axis, we're going to try reflecting this one in the y-axis. So this is going to end up being reflected in the y-axis. Okay, so that means that this line here is now going to be our mirror line. That's the line that we are trying to figure out how far away the point is from. So A, right now, point A is at -2 on the x and +4 on the y. Let's see what happens to it when we reflect it. Well, this is our mirror line, and so we see how far point A is away. It's 2 spots away. And so we go the same distance, or as we're going to see later on, equidistance in the opposite direction. 2 spots away. And this is our new point A. We show that with a little line next to it. And point A has now changed to 2, 4. Let's take a look at point B. Right now, point B is at 1, 2, 3, -3 on the x, and 1, +1 on the y. When we reflect this in the y-axis, it's 1, 2, 3 spots away. I continue 1, 2, 3 spots. I get my new point B, which is at +3, 1. Let's take a look at our final point, point C, which right now is at -1 on the x and -2 on the y. Sorry, -1 on the x, -2 on the y. I want to reflect that. It's 1 away from the reflection line. I continue that 1 past it. Draw my point there, point C. And now point C, the new point C, the reflected point C, is going to be at +1, -2. The only thing left to do is to connect the dots to create our brand new shape. And if you see, this shape here looks like it's just been reflected or flipped in that line, the y-axis, that acts as our mirror line or our reflection line. If you take a look at our coordinates, you'll notice something a little bit interesting too. When we reflected in the x-axis, the only thing that changed is our y value changed signs. When we reflect in the y-axis, our y's actually stay the same, and our x values change signs. So that's kind of an interesting little thing to note when we're taking a look at an easier way to understand how the coordinates might be affected, even if we are not drawing this graph. Let's take a look at a couple of rules connected with reflection. We have 4 main ones that we're going to take a look at. The first is this. The original object and the image are congruent. So if we take a look at this picture here, we would say that triangle ABC, that's the original object. We would say that object ABC here, with the lines next to it, that's the image. That's the reflected image. And we'll notice that they're actually both congruent. If you remember back from our very first video, we talked about something is congruent if it has the same angles, and these ones have the same angles and the same side lengths. And so these are essentially the exact same shape, just a flipped version or a mirrored version of it. Point number 2. Any point A and its image A are equidistant from the line of reflection. What that simply means is here, this point A is 2 spaces away from the mirror line. So this also is the exact same thing, 2 spaces away from the mirror line, just in the opposite direction. Point 3, the line of reflection is the perpendicular bisector of the segment joining every point and its image. So this definition is a little bit trickier to understand. What that basically means is that if we were to create a line segment joining point A here and its reflected point A here, then the mirror line would be perpendicular to it, and we talked about that means going in exactly the opposite direction to it. And a bisector, which means exactly in the middle. It splits this line connecting them right in 2. The last point here is that the orientation of the object and that of the image are different. So what that means, orientation is the way that it's facing. This is not an exact copy of this. Even though they are congruent, it's a flipped copy of it. So the way that it's facing is slightly different, in fact, is exact opposite to the object that's over here. Let's take a look at 2 more examples as we try to understand how reflection works. Now, previously we took a look at an example where we reflected in the x-axis or we reflected in the y-axis. But sometimes those are not our mirror lines. Sometimes our mirror lines are in other spots. Here, for example, our mirror line is actually at x equals 2. What that means is that wherever x equals 2, which is right at this spot here, every point along this line is x equals 2. Y could equal all sorts of different things, but it's x equals 2. So that's our mirror line, and so that's going to change where things reflect. We're just going to take a look at a really simple triangle here. So we're going to have a point here, as well as a point here, and we're going to see how those reflect. We'll call those point A, point B, and point C. Let's connect our nice triangle. And we're going to try to see how those reflect in that particular mirror line. So point A right now is at 2, -1. Point B is at 3, +1. And point C is at 5, -1. So because we are reflecting in this mirror line goes straight up and down. So we are going to go straight left and right, the exact opposite or perpendicular direction, in order to figure out where the new point is going to be. I'm actually going to leave A to the end, because A is a bit of a trickier one here. So let's start with B, we'll go to C, and we'll end off with point A. So point B is only 1 spot away from that mirror line. I continue 1 spot past it, and I have my new point B. Now the tricky thing here is our rule about the x and y axis do not apply when our mirror line is somewhere else. So in this example, I have to go through again and I have to see how exactly that works. So our new B location is going to be at 1, 1. The one thing you can figure out is because this is a value here that kind of acts as a y-axis that moves, we know it's only going to be our x value that changes. Let's take a look at point C. Point C here is 1, 2, 3 spots away. I continue, 1, 2, 3 spots away. There's our new point C, which is going to be at -1, -1. Now, point A is a little bit of a strange one. Point A is on the mirror line. And so it is 0 distance away from it, which means that it moves 0 distance in the other direction. So point A, because it's on the line, does not move its position. It stays exactly where it is. And so A and A naught, or A with the line next to it, are the same point. Now I draw my shape here, and we see that it is a reflected image. If I were to put a mirror right here, this is what the image would look like on the other side. Let's take a look at one last example. And this example has a bit of a strange mirror line. It's not straight. Or it is straight, but it's not straight up and down or straight left and right. It's a straight angle. And so our reflection is going to look a little bit different when we draw our shape. Let's draw our shape first of all. So let's do point A, let's do point B, and we'll create point C up here. Just going to connect those together. Just to identify where those locations are. Point A is at -2, +2. Point B is at +2, +3, or 2, 3. And point C is at +1, 4. Because this is our line now, horizontal or to go perpendicular to it, I have to go on an angle in the opposite direction. So B, there's a couple ways I can do this. I can either say that B is kind of half a square across, and so I continue half a square and I end up here, or I can deal with left and right. So I'm 1 to the left, or 1 to the right, sorry. And so because this is on an angle, I have to counter that with 1 down. So I can either go right and down, or I can go on that angle. It still gets me to the same spot. So here's my new point B, which is now at 1, 2, 3, and 1, 2. Let's take a look at point C. Point C, I can either go on an exact angle, 1, 2 away, or 1.5 away, I guess, and go 1.5 away, and I have my point there. Or I can say I go 1, 2, 3 to the right, and then 1, 2, 3 down. The reason why I'm not going in the same direction is because we're on an angle. And so what I'm doing is I'm actually creating kind of a bit of a triangle there, where this would be the same distance intersected by that mirror line. If that's a bit too tricky for you, don't worry, we're just going exact opposite or perpendicular to that line. So our new point C is going to be located right here at 4, 1. Point A, if we take a look, we're 1, 2 away from here if we go on an angle, or 1, 2, 3, 4 if we go across. So I can either go 1, 2 on an angle, or 4 down, and I get exactly to that spot there, A with the line to it, connect my lines, and you see that I have a reflected image of triangle ABC on this side of the mirror line. And if I were to put a mirror here, this is exactly what it would look like as a flipped image. You can kind of think of if I were to paint this triangle here, and this is where I folded the paper, that's where that paint or that stamp or whatever else you're working with would show an image on. And so our new point A here is at 2, -2. So in this one, we actually had an interesting, strange connection here. that when we do have a line that goes exactly crossing through the origin here, and it's one that is at this exact angle, then we kind of just ended up swapping or switching our x and y values. We don't always have that happening. But in this example, we ended up having that happen in our reflection. We're going to do a lot of more work with reflection, as this is one of the first ways that we can transform the object of a shape. In future videos, we're going to learn how to do more transformations as we learn how to translate the location of a shape, as well as rotate the reflection of a shape.